Hey, good morning, everybody. This is Mr. Aynesworth again, and we're in financial algebra here at Great Oak High School in section 10 of chapter 2. And so in this video here, I'm just going to select a few key problems from section 10 that I want to focus in on here. So let's go to number 7 through 10, okay? In class, I've already done quite a few of these here, skipped a few, did a lot, read Canvas for the ones you have to do, but I want to focus in on 7 through 10. And when we do this here, do all your work when you're spiral. There's not enough room, obviously, in these teeny little spaces to do all your work. So do all of your work in your spiral. And that's kind of standard. Also, get Desmos ready. And then save your work in through here. Just type in some keywords here, like section 210. All right, finding the term of an investment of a systematic or periodic investment. That's what I wanted to say. Of a systematic account or an investment. So always save your work. We use Desmos here in this class a lot just because you can save all your work. It's a great online calculator tool. Okay, number 7 here. iPartner is an online bank that offers a locked-in interest rate of 3.6% compounded monthly. Okay, so right there, some key things in this problem here. So R is 0.036. It's compounded monthly, so N is 12. And because this is a compounded monthly problem, we need to use the compound interest function. So compound, when you're compounding n times, whether if it's monthly, n is 12. If it's quarterly, n is 4. If it's annually, n is 1. But if you're compounding n times, then the future value is equal to the principal times 1 plus r divided by n raised to the nt power. That's if you are compounding n times. The future value b is equal to the p, the original deposit, times 1 plus r divided by n to the nt power. Now, if you do things in a compound continuously fashion, like in number 8, that's different. We'll talk about that in a minute. Okay, so let's go ahead and get started on the problem. Rich makes the initial deposit of $10,000, so the principal is $10,000. How long does it take to keep the money in the account in order to have a balance of $12,000? Okay, so we want a future balance of $12,000. That's B. Okay, future balance $12,000. So how long does he have to keep it in the account to go from $10,000 to $12,000? I don't know. That's part of the problem, right? Okay, so you have to understand. It says right here, how long does it take? Okay, T. I don't know what T is. How many years? This is always in years. How long would this take to make that happen? So let's go ahead and set it up over here. Okay, this is number 7. All right, and I'm going to be using the compound interest formula. So we want 12,000 initially, or excuse me, in the future. That's B. All right, and again, it's B is equal to P times 1 plus R divided by N to the NT power when you're compounding. We want 12,000 in the future. If we put 10,000 in, that's your original principal, multiplied by 1 plus R, which is 0.036, divided by 12, because we're talking about monthly here, raised to the NT power or 12T power. So you got to set it up here, and then you got to solve it. Whenever you solve equations like this in the exponent here, notice that our time is in the exponent, so it's right up there. It involves logarithms, but before you do that, you isolate your exponential. So divide both sides by 10,000. All right, and then simplify, like that's 1, of course. Cancel out the leading zeros, you get 12/10. If you want to simplify that to 6/5, be my guest. Okay, or if you want to write it as a decimal as 1.2, that's fine too as well. You guys can do what you want to do there. And then you can simplify this decimal here too, but if you want to just leave it like this, that's fine, because decimals is going to do the work anyway, so it doesn't matter if you simplify that or not. Okay, and then at this point you want to take the log of both sides, because you can't shift the exponent until you're in log form. So let's take the log, the common log of both sides. LOG is the common log base 10. There's different ways to do this. This is one of 2 different methods of how to handle this. Once you're in log form, you can take the exponent here and shift it to the front of the log. Okay, that's one of the log properties, the exponent property of logs. So shift exponent, all right, to front of log. Okay, that's a key concept right there. Okay, when you do that, you get log of 6/5, that's the left, and then you get 12t times the log. 12t times the log 1 plus 0.036 divided by 12. Now you're trying to solve for t, the time. Okay, that's called the term. Okay, the number of years for the account that go from 10,000 to 12,000. Well, to do that, to isolate t, I need to divide both sides by 12 to cancel out the 12. I need to divide both sides by the log to cancel out the log. So I'm going to do two steps in once, so it's more efficient that way. More efficient meaning faster and easier. Okay, and obviously over here these divide to 1, giving you t. All right, t. So what is that? I don't know. Let's go to Desmos now. That's why I have Desmos up and running here, and let's enter in this expression right now. So hit function, select miscellaneous, and then hit log. Okay, of 6/5, so 6 divided by 5. We want to divide that by 12 times the log of 1 plus 0.036 divided by 12. And you'll notice that we get about 5.07 years. Okay, 5.07 years. Man, the publisher says 5 years. They obviously rounded. Okay, so if you check that with the publisher's answers, they will say 5 years, and of course that's close to 5, right? Right. Okay. Oh, in fact, you know what? I just noticed something. It says rounded to the nearest year. Nearest year, and guess what? So that's 5. So t is equal to 5 years. Okay, there's number 7. Okay, now number 8. Number 8. Danka opened a savings account that pays 1.8% interest. So right there, you know that R is 0.018, but it's compounded continuously. And once you know that, you have to use your compound interest or compounded continuously interest function. And notice that's different. So if it's compounded continuously, we're going to switch functions and use this one. You only use the previous function if it's compounded n times, like compounded monthly, quarterly, annually, daily, okay, hourly, whatever. All right, but if it's compounded continuously, you have to switch functions. All right, her initial deposit was 160 bucks. Okay, so let's go back to the problem. So I know right here that's P. So $160 deposit. How long will it take? I don't know. T is equal to question mark, right? How many years will it take to leave the money in the account for it to reach 250? So you want the future value to be 250 bucks. So you're going to go from 160 to 250. So obviously that's in the future. So to solve this, we take we got 250. 250 here is equal to 160 times e to the 0.018 t. That's your initial setup. Okay, now to solve this equation, let's see here. I need some more room. So you know what? I'm going to go down here. This is number 8. Okay, so I got 250 here is equal to 160 times e to the 0.018 t. Now let's focus in on number 8 now. I'm going to divide both sides by 160. Okay, always isolate your exponential. Cancel out the leading zeros and you get 25/16. Okay, so 25/16. And you don't need a decimal there. You can just keep it that because you're going to let decimals do the work. Okay, so you don't have to worry about changing to a decimal or anything like that because decimals is going to do it. Now, since it's base e, I'm going to take the natural log of both sides. There's a reason for that. It doesn't matter which base you use, but here it's going to be easier to use the natural log. Once you're in log form, you shift the exponent. It can only be done in log form. Okay, so here we go. So we've got the natural log of our 25/16 is equal to 0.018 t times the natural log of e. Okay, now you have to understand that natural log of e here, that's just 1. All All right, e to the first power is, you got to be thinking. Oh, let me sidetrack here. The natural log of e is the same thing as log base e of e. So you got to be thinking, e to what power gives you e, and of course that's got to be 1. Even if you type in the Desmos here, you type in the natural log and you type in e, it'll tell you it's 1. See? Natural log of e is 1. So knowing that right there, let's continue here. All we have to do is divide by 0.018 and we're done. Okay, so we get t is equal to something here. And once again, we go to Desmos and we work it out. So just type it in. So type in the natural log. ln stands for the natural log of 25/16. Okay, and you want to divide that by 0.018, and you get about 24.8 years. So 24.8 years. There we go. All right, now, and if this is a video, you guys, so as with all videos here, you guys can go at your own pace, so just keep that in mind. You go at your own pace. If you have to rewind this, listen to it again, you do whatever it takes. All right, let's transition to the new ones, though. Numbers 9 and 10 are important because they're new. Okay, so let's label them. These are the key problems in the entire lesson here. Test question here. TQ, a little hint, okay? You got to be able to do this stuff. And number 9, Bill wants to make monthly deposits. Right there, this is periodic, okay? So the fact that it says monthly deposits, he's going to be depositing $75 per month. You need a periodic, what's called the periodic investment formula. Periodic investment formula, which is this one here. So the future value of any periodic investment is given by P times the quantity 1 plus R divided by N to the NT power minus 1, all divided by R divided by N. Okay, so this is something that we've dealt with before, but this time we're going to solve for T. So Bill's going to be making monthly deposits of $75. So right there, your monthly periodic amount is $75 per month. Okay? That is your periodic deposit. Now it says R right here, R is 0.027, all right? The interest rate is 2.7%. As a decimal, it's 0.027. And it's compounded monthly here, so N is 12, okay, because we're talking about monthly. What's the future balance here? That's B, okay? B is the future balance. That's equal to B, all right? And then it says, how long will it take for the account balance to reach 2,000? So Bill's going to be making these monthly periodic deposits, $75 per month, every month, and then sooner or later you're going to have $2,000 in the account, But after how many years, right? It says, how long will it take? Again, how long will it take? T equals question mark. That is the question. Okay, so I'm going to do number 9 down here below here so that I need some room down here. Okay, number 9. Here we go. So I need to substitute my numbers in. So the future balance is 2,000. And by periodic deposit that I'm going to put in here, or Bill's going to be putting in, is $75. And I got to multiply it by 1 plus R divided by N, which is 0.027 divided by 12, raised to the 12t power. It's always raised to the N times t power, minus 1, all divided by 0.027 divided by 12. That, my friends, is called the setup, okay? Remember, he puts in $75 monthly. The question is what's T after how many years? What's T to reach $2,000 into the account? That's what's going on. So when I handle this right here, personally, I would cancel out this fraction in the denominator. I would multiply both sides by 0.027 divided by 12. Okay, I would multiply both sides by it. All right, and what's going to happen is that these fractions are going to cancel out on the right-hand side, giving you something a little bit more simple. On the left-hand side, I would definitely work this out. So I would simplify this 0.027 times 2,000 divided by 12. I would figure that out. And notice it's 4.5. So this right here is just 4.5. The fractions cancel out on the right, and it gives me 75 times 1 plus 0.027 divided by 12 to the 12t power minus 1. Okay, now so let's go back up here. So at this point, you got to cancel out the minus 1, you got to cancel out the 75. So I would just divide this by 75, something easy to do here. All right, 75 divided by 75 is 1. The question is what's the left-hand side? So 4.5 divided by 7.5, that's just 0.6. See, pretty straightforward. So 0.6 is equal to 1 plus 0.027 divided by 12 raised to the 12t power minus 1. At this point, you got to add 1 to cancel that out. Okay, and at this point, this point, 1 plus 0.6 is 1.6. Hopefully that's obvious. Now, we're not in log form, so you cannot shift the exponent yet. You got to take the log of both sides. So to use your log property rule. So I'm going to use the common log here. I'm going to take the log of both sides. I'm going to get it in log form. And once you have it in log form, once again, you can shift the exponent to the front of the log where you need it. Okay, so let's do that. So I would get the log of 1.6 on the left, and that's equal to 12t times the log 1 plus 0.027 divided by 12. And notice that I don't simplify that decimal, because decimals is going to do the work. You don't have to worry about it. So I need to divide both sides by 12 to cancel out the 12. I need to divide both sides by the log to cancel out the log. So you do two steps simultaneously to be more efficient. And so the logs cancel out to 1. And all I need to do is now evaluate it using Desmos. So go to Desmos, enter in log. This time the common log of 1.6. And we're going to divide it by 12 times the log. 1 plus 0.027 divided by 12. What happened here? Something is wrong. Okay, let me see what happened here. That's not the correct answer. What happened? Okay, I just figured out my little mistake here. Going back a few steps here, I took 4.5 and I divided by 7.5 for some silly reason, so that was incorrect. So I'm going to fix that. So 4.5 divided by 75 is 0.06. So I'm going to fix this here. I've got to fix this. So it's 0.06. 0.06 plus 1, 1.06. 1.06, and then this is 1.06, 1.06 here. So now I can fix my work. I gotta just fix this. I knew I made a mistake here. There we go. That's the correct answer there, 2.16 years. So 2.16 years, roughly, and they round that to the nearest year, so 2.2 years to the nearest tenth here. There you go. Okay, so even I make mistakes sometimes. I don't know why I put a decimal in there. I was supposed to take 4.5 times, or divided by 75, not 7.5. I don't know what I was thinking right there. Okay, but that is how you handle number 9, my friends. Okay, number 10 is very similar. So, might as well do it. Okay, so number 10, we'll do it right here off to the side. Okay, so number 10, Graziella here makes quarterly deposits of $800. That's per quarter. Okay, so N is 4. It's per quarter here. P, the monthly or periodic deposit right here, quarterly deposit is $800 into account that pays 1.8%, so R is 0.018. and it's compounded quarterly, so n is 4, right? N is 4. And then how long will it take? I don't know how many years to reach 20,000. So the future balance is 20,000. So here we go. So once again, I'm going to start off with the periodic formula here. So $20,000 is equal to your monthly, quarterly, periodic deposit, which is 800 here, times 1 plus 0.018 divided by 4, because it's quarterly, raised to the 4t power, minus 1 divided by 0.018 divided by 4. Now at this point, you multiply by your fraction. So over here, 0.018 divided by 4. So multiply on the right, multiply on the left. You know, always do the same thing. At this point, probably want to kick in a little decimal, so let's do that. Okay, so I got to enter in 0.018 divided by 4. All right, oops, divided by 4. And then I want to multiply by 20,000. Okay, and that's 90. Cool. Okay, so that's a little bit simpler there. So we get 90 here is equal to 800 times 1 plus 0.018 divided by 4 raised to the 4t power minus 1. At this point, you want to divide by 800. All right, simplify a little bit, cancel out the leading zeros. So you get 9/80ths here. So 9/80ths is equal to 1 plus 0.018 divided by 4 raised to the 4t power minus 1. Now if you want to, I don't know if, let's divide 9 by 80. I think this is a repeating decimal. No, it's not. Okay, so 0.1125. So 0.1125 is equal to 1 plus 0.018 divided by 4 to the 4t power minus 1. At this point, I would definitely add 1. Let me just, okay. Everybody focus in on the middle here. Okay, so I'm going to add 1 here, add 1 here. Simple. So 1.1125 is equal to 1 plus 0.018 divided by 4 to the 4t power. And once again, you cannot shift any exponents until you go to log form. So you got to take the log of both sides. So log of 1.1125 is equal to the log 1 plus 0.018 divided by 4 to the 4t power. Once you're in log form, which we are now, you can now shift the exponent to the front of the log, as I keep on repeating myself. It's the same thing every time. So I take log of 1.1125 is equal to 4t times this crazy log, 1 plus 0.018 divided by 4. Then just do your division on both sides. Divide by the 4, divide by the log. And once again, if I go too fast, pause the video, okay? Rewind it if you need to. All the process, this entire thing is always the same, okay? It's the same thing. Okay, so at this point, we enter it in Desmos. What is t? Okay, you're trying to find t. So we go to Desmos now, and we type it in. So now, the last calculation here, so log of 1.1125, all right, close it off, divided by 4 times the log, all right, at 1 plus 0.018 divided by 4. And you get about 5.9 years. There we go. So that's it, my friends. 5.9 years. Okay, and that, my friends, was number 10. Okay, so number 9 was on the left-hand side. Okay, like right here. Number 9 is on the left, number 10 is on the right, and then number 8 is on the far right. Okay, that's why I always say take out your spiral, guys, because there's no way you can do all your work here in these little spaces in your workbook. Okay, use your spiral. All right, if you need any more help than that, let me know in class here. I'm available, and I will see you guys later. Take care. Bye-bye.